Hello students, welcome to an electrifying mega practice session on the topic Electrostatic Potential and Capacitance for class 12 physics. I am Sapna Soni, your host for today's 90 conceptual question. So get ready to sharpen your understanding and ace those exams. Don't forget to like, subscribe and let's begin to the journey of electrification. That is the first question which we will take. That is, electric lines of force always leaves an equipotential surface. The first option we have, at any angle to the surface, parallel to the surface, perpendicular to the surface, none. So let's see the solution of this part. Equipotential surface is always perpendicular to the surface. That means the correct option is option 3. Move ahead with the next question. A unit charge is taken from one point to another over an equipotential surface. Then, work is done on the charge, work is done by the charge, work on the charge is a constant, no work is done. So, the solution which we have, the potential difference along the equipotential surface is 0. So, work done is 0. Hence, the correct option for this question is option 4. Next question which we have. Inside a hollow spherical conductor, the potential is constant, varies directly as the distance from the center, varies inversely such that the distance from the center varies inversely as the square of distance from the center. So, let's see the solution. Inside a hollow spherical conductor, the dielectric field is 0. Hence, potential is constant. So, we can say that the correct option is option 1. Next question which we have, choose the correct statement. So, we have a statements are, an electron at a higher potential has a lower potential energy. An electron at a lower potential has a lower potential energy. An electron moves from higher to lower potential. None of the above. So, let us see the solution of this question. The potential energy of a charged particle in an external field is Q into V. That means, electron at a higher potential has a higher potential energy. At lower potential energy. According to this, the correct option is, which we have, second. That means electron moves in the direction opposite to the field, that means lower to the higher potential. Next question which we have. Choose the correct statement. The first, a charge potential, a zero potential point is always a zero electric intensity point. A zero electric intensity point is always a zero potential point. At a point of a zero electric intensity, electric potential may not be zero. All the above. So let us see the solutions. A zero potential point may not be zero field point. For example, if we just taken a charge Q and minus Q, Q and minus Q are placed at four corners of a square, electric field is not equals to 0, but potential is 0. That means a point or a zero field point may not be zero potential point. For example, hollow charge conducting a spherical cell. So what we concluded? We concluded at a point of zero in electric intensity, electric potential may not be 0. That means the correct option is 3. Next question which we have. When the separation between two charges is increased, the electric potential energy of the charges increases, decreases, remains the same, may increase or decrease. Solution we have. We know that the formula U is equals to K, Q1, Q2 divided by R1 minus R2, where K proportionality constant. And the value of K is 1 by 4 pi epsilon naught, which is equals to 9 10 to the power 9. So, if the separation increases, U may decreases, and it depending on the nature of the charges. That means the correct option is 4th. Now, we have in the next question, choose the wrong statement. The first we have an equipotential surface is normal to the electric field lines. Potential increases in the direction of electric field. We may have zero potential but non-zero electric field at the point in a space. Potential is an scalar quantity. So solution, let us see. Potential decreases in the direction of electric field. That's why we can say that potential increases in the direction of electric field. Is the wrong statement. How this statement will be true? So we know that electric field is a negative gradient of a potential energy. By this statement, we can easily say that when the electric field decreases, potential changes accordingly. Next question which we have, out of the following two statements, as we move in the direction of the field, potential goes on decreasing. The second we have option, if a charged body is moved within the field, work must be done by the field. So these are the two statements which we have to find out in this two statement which one is according to the option, which one is belong correct. So A is correct and B is wrong. A is wrong and B is correct. Both A and B are correct. Both A and B are wrong. Let us see the solution. When a charged body is placed in an external field, a force acts due to the field. Hence, work is done by the field. According to this, the correct option which we have of both A and B are correct. Next, we have a question. Potential at the point of a pointed conductor is maximum, same as at any other point, 0, and minimum. Let us see the solution. So according to the conceptual data, so the same as the any other point. Potential at a point of a pointed conductor is the same as the any other points. Next we have, out of the following two statements like these, three charges cannot have a zero mutual potential energy. The mutual potential energy of a system of a charge is only due to the positive charge. A is wrong and B is correct. A is correct and B is wrong. Both A and B are correct. Both A and B are wrong. Let us see the solution of this question. Any two systems of charges can have a potential energy and any system can have a zero potential energy. According to this, both A and B are wrong. Next question we have, if two conducting spheres are separately charged and then brought into contact, the total energy of the sphere is conserved. The total charge on the sphere is conserved. Both total energy and charge are conserved. The final potential is always the mean of the original potential of the two spheres. Solution we have, when two conducting charge spheres are brought in the contact, charge is only conserved. As the spheres are charged separately, there may be change of energy. According to this, we have this correct option is option 2. Electric potential at some point in a space is 0. Then, at that point, electric intensity is necessarily 0. Electric intensity is necessarily non-zero. Electric intensity may or may not be 0. Electric intensity necessarily infinite. Let us see the solution of this question. So we have when potential at the point is 0, field may or not be 0. According to this, the correct option is 3. Next question we have. At each corner of an equilateral triangle, identical charges are placed. Then, at the center of the triangle, the resultant electric intensity is 0. At the center of the triangle, the net electric potential is 0. The electrostatic potential energy of the system is 0. The resultant electric intensity at corner is 0. Now, let us see the solution of this question. For identical charges at the corner of the equal triangle, the resultant electric field is 0, but not potential. Hence, at the center of the triangle, resultant intensity is 0. Next question we have. On the perpendicular bisector of an electric dipole, the electric intensity E and potential V are E is equals to 0, V is equals to 0. E is not equals to 0, V is not equals to 0. E is not equals to 0, but V is equals to 0. E is equals to 0, but V not equals to 0. So let us see the solution of this question. On the perpendicular bisector, potential is 0 because the charges are equal and opposite, but the field is not 0. So, according to this, the correct option is third. Next question we have, when an electron approaches a proton, their electrostatic potential energy decreases, increases, remains unchanged, all the above. The solution of this question is, proton and electron are opposite charges which attract each other and potential energy decreases. That means the correct option is a 1. Next question we have, the mutual electric potential energy of two negatively charged particles are U1 and U2. When their distances of separation are d1 and d2 respectively, if d2 is greater than d1, then u1 is greater than u2, u1 is less than u2, u1 is equals to u2 and cannot be decided. So we have a solution. As we know that u is inversely proportional to the distance, so we can say that the first option is the correct. Next we have, if an earth plate is brought near the positively charged plate, the potential and capacity of a charged plate increased or then decrease, decreases then increase, decreases and decreases, increases and increases. So the solution which we have, capacity increases because more charges accumulate to the positive plate, and potential decreases because opposite field against the field between the plates decreases. Then first increase and then decrease. According to that, like the potential decreases and capacity increases. So next we have a question. At a point in a space, the electric field point towards north in north region. Surrounding the point, the rate of a change of potential will be 0 along north, south, north-south and east-west. Let us see the solution. As the field direction towards north, so equipotential is east-west. So the rate of a change of potential is 0 in that direction. That means we can say that the correct option is option 4, which is the east-west. Next question we have, the charged sphere of a radii 10 centimeter and 15 centimeter are connected by a thin wire. No current will flow if they have the same charge on each, the same potential, the same field on their surface, the same energy. Let us see the solution of this question. No charges or no current flow if the points are at the same potential. That is, the potential difference between the point is 0. According to this, the correct option is option 2. Next question we have, an electron and a proton moves through a potential difference of a 200 volt. Then electron gains more energy, proton gains more energy, both gain same energy, none gain energy. So we have a solution. Work done is equals to kinetic energy, gain is equals to electron volt. Hence, both electron and proton will gain the same kind of energy. According to this, the correct option is 3. Next question we have, an electron of mass m and charge e is accelerated from rest through a potential difference v in vacuum. Its final speed will be, these options are here. Let us see the solution of this question. We know that for kinetic energy is always equals to the potential energy because of the conservation principle. So if we find out the value of a V, so we will get under root 2 eV electron volt divided by mass. According to this, the first option is the correct option. The next question which we have, 4 identical charges, each of a charge of are placed at the corner of a square. Then, at the center of the square, the resultant electric intensity E and the net electric potential VR. We have an options are, electric field is not equals to 0, potential is equals to 0. Electric field is equals to 0, potential is not equals to 0. Electric field is equals to 0 with the potential V is equals to 0. And the last we have, electric field is not equals to 0 and potential is not equals to 0. This is the diagram of this question. So as you can see that these are the 4 charges which are located at the vertices of the square. So solution we have all the identical charges. So C is not equals to 0. Due to the symmetricity, we can say that EC is equals to 0. According to that, the correct option is option 2. Next question we have, electric potential on the surface of a hollow conducting sphere is V. The electric potential is V by 2 at the distance R by 2 inside the sphere, R square by 2 from the surface of the sphere, and outside it 2R from the center of the sphere, 2R from the sphere, surface of the sphere, and outside it. So the correct option, which is option 3rd. Let us see the solution of this part. So we know that V surface is a K Q by R. Now V prime is a V by 2. So K Q by R. If I just put all these values, so we will get R prime is equals to 2R. According to this, the correct option is 3. Next question we have, a charge Q is at the center of a semicircle of a diameter AB. If work done in moving a charge Q along the semicircle is W1 and work done in moving the same charge Q along the path ACB is W2, then W1 is greater than W2, W1 is less than W2, W1 is equals to W2 is equals to 0. W1 is equals to W2 is not equals to 0. This is the diagram. Let us see the solution of this question. Electric field is a conservation or conservative field. Hence, work done is independent of the path. A and B are equipotential surface. So, we can say that W1 is equals to W2 is equals to 0. According to that, we have the correct option. W1 is equals to W2 is equals to 0. That is the third option. Next question we have 25. A charge Q is placed at the one corner A of a square ABCD. Its center is 0. A test charge Q is moved along three paths, namely BC, BCD, and BOD, doing the work W1, W2, and W3 respectively. Then W1 is equals to W2 is equals to W3 is equals to 0. W1 is a greater than is a W2 is greater than W3. W1 is not equals to 0 and W2 is equals to W3 is equals to 0. W1 is less than W2 is less than W3. This is the diagrams. Let us see the solution of this question. So, VB is a greater than VC and VA is equals to VC from this diagram. We can say that W1 is not equals to 0 and W2 is equals to W3 is equals to 0. Next question we have. In hydrogen atom, electrons of electric charge, that is a minus E, and mass revolves around the nucleus in a circular orbit of a radius small r. The electrostatic potential energy of the electron is a 1 by 4 pi epsilon naught times minus E by r minus E square by r, E square by r, and minus ME square by r. Let us see the solution of this question. So, electrostatic potential energy of electron is potential of the nuclear field at distance r into charge of electron. That means E into minus E divided by 4 pi epsilon naught. According to this, 1 by 4 pi epsilon naught into minus E square by r, by which we can say that we have a second option is the right answer. Next question we have it. In the electric field of the potential of a point charge Q, a certain charge is carried from point A to B to C, D and A. Then the work is done. We have Q is at the center of the circuit. Options we have least along the path AB, least along the path AD, 0 along the any one path AB, AC, AD and AE, least along the E. So let us see the solution of this question. Electrostatic field is a conservative. That's why we can say that 0 along any one of the path AB, AC, AD and AE. Next question we have. The conducting sphere of radii R1 and R2 are at the same potential. Their charges are in the ratio of R1, R2 ratio R1, R2 by R1 whole square, R1 by R2, R1 by R2 whole square. We have solutions. V1 is equals to V2 when they are connected, or there will be a line directly will be mentioned the same potential. So V1 is equals to V2. We just put all these values and get the result like Q1 by Q2 is equals to R1 by R2. According to this, the correct option is option 3. Hope you understand this much. Next question we have. A condenser is charged to a potential V by connecting to a battery. If the charge on the condenser is a Q, the energy stored in the condenser is 1 by 2 times a QV. The work done by the battery during the charge is the half QV. The work done by the battery is the charging is a QV. Both 1 and 3 is a 2. So we have solutions. When a capacitor is charged by connecting a battery of a potential V, work done by the battery which is a QV. Energy stored in the capacitor is a half QV. According to that, both 1 and 3 is a true. Next question we have. Identify the correct order in which the gain in kinetic energies increases in the following cases. Alpha particle accelerated through a potential difference of a 2 volt. Proton accelerated through a potential difference of a 2 volt. Deuteron accelerated through a potential difference of a 3 volt. Electron accelerated through a potential difference of a 5 volt. We have an options these. So let us see the correct answer for this question, which is a 1. That means the correct order is proton accelerated through the potential difference of a 2 volt, deuteron accelerated through a potential difference of a 3 volt, alpha particle accelerated through a potential difference of a 2 volt, and electron accelerated through a potential difference of a 5 volt. Let us see the solution of this question. How? I'll just say these kind of things. Kinetic energy is equals to Q into E. Kinetic energy is equals to 4 electron volt. Second have for proton 2 electron volt. Third we have a next particle deuteron have a 3 electron volt. Next electron have a 5 electron volt. According to this, the correct option is option 1. Next question we have when a charged particle of a charge Q and mass m are accelerated through a potential difference of a v, then velocity v acquires by it is v is directly proportional to the m to the power minus 1 by 2. V is directly proportional to the potential difference capital V, and V is directly proportional to Q to the power half. Let us see the solution of this question. So, for that we have in things B is correct, both A and C, B and C are correct, both B and D are correct, A and C are correct. So, B and D are correct, but how it will be? Let us see. We know that the potential energy QV is equals to kinetic energy, which is a half mv square. So V is equals to under root 2 QV divided by m. According to this, we can say that V is directly proportional to Q to the power half, V to the power half, and m to the power minus half. That's why we can say the correct option is option 3. Next question we have. When n identical drop each of potential V coalesces to form a bigger drop of a potential V1, then V1 is directly proportional to n. V1 is directly proportional to the n to the power 2 by 3. V1 is directly proportional to the V to the power 2 by 3. And V1 is directly proportional to V. So, we have an options are A and C are correct, A and D are correct, B and C are correct, and the last option we have B and D are correct. Let us see the solution of this question. So we know that the volume is 4 by 3 pi r1 cube is equals to n times 4 by 3 pi r cube. According to this, we can say r1 is equals to n to the power 1 by 3 times of r, or v1 is equals to 1 by 4 pi epsilon naught n q divided by n to the power 1 by 3 times of r. Hence, we can say that n to the power 2 by 3 times of v is proportional to or directly equals to v1. That means B and D are correct. Next question we have. Two concentric spheres of radii r and small r have similar charges with equal surface density sigma. The electric potential V at their common centers is V is directly proportional to the sigma by epsilon naught. V is directly proportional to the R plus R. V is directly proportional to the R minus R. And V1 is proportional to the sigma R minus R. We have these options. Let us see the solution, how to solve this particular problem. So, this is the diagram. Inside and the outside, the densities are same, but the radius are different. So, as we can see that V is equals to V1 but not equals to V2. So if I just put all these values, we get an equation that is a k minus 4 pi r plus r. From this we can say that sigma by epsilon naught r plus r is the correct answer, which is option number 1. Next question we have the match list first with list second. List 1. Electric potential inside a charging conducting sphere. So we have these kind of a list. Firstly, I'll just make this list. Yes. So we have to match it out. We have an options are these. Let us see the solution of this question, how we did the correct options. So, as the field inside a conducting sphere is 0, that means potential is a constant. Second, for electric potential conducting sphere, V out is equals to KQ by R. Electric field inside the non-conducting sphere, E inside is equals to KQ by R cube into R. And electric field outside the conducting sphere is a KQ by R square. According to this, the correct option is 4. Next question we have a match the list with the list. Firstly, we will make the list. We have an options. Now let us see the solution of this question. So, when two like charges are brought nearer, potential energy increases. When unlike charges are brought near the potential energy, it will be decreases. Mutual forces are not attached or attract. Due to the dielectric medium, force between the charges decreases. Hence, the correct option is second. Let us see the second option is a what? Second is A means F. A, F, that means two like charges are brought nearer. There will be potential energy of the system increases. Likewise, you have to match it out. Next question we have again the match the following from these we have a list and these are the options. Solution we have also like a V is equals to V naught like 1 by 4 pi epsilon naught Q by R. This is the naught theta. This is a Q by R. E is equals to minus dy by dr or dx. We just put this value and get the result that is the equipotential energy or electric potential energy is equals to force into displacement is equals to QED. According to that, the first option is the correct. Next question we have a match list first with the second list. So this is the list 1, this is the list 2 with the points D option mentioned. So here the options are given. Let us see the solution of this question. Electrical energy is stored in the capacitor in the electric field between the plates. Capacity of a capacitor increases when the dielectric is introduced between the plates. Potential difference decreases, remains same. That means we can say that we have an options. According to that, the correct option is option 3. Next question we have statement first. When a proton with a certain energy moves from low potential to high potential, then its kinetic energy decreases. Second statement we have the direction of electric field is opposite to the direction or potential gradient. Options we have the first option of the first statement is a true, second is a false. Okay. First statement is a true, second also true statement, second is a correct explanation of the statement first. Statement first is true, second statement is true, but statement second is not the correct explanation of the statement first. Statement first is true, statement second is a false. Statement first is a false, statement second is true. So the first statement is a correct with the second. Now, and the second one is the first explanation in a very fluent way. So let us see the solution of this question. When proton moves from a lower potential to the higher location, that is in the direction opposite to the field, it is a decrease. That means E is equals to minus d by dx. According to that, the correct option is option 1. Next question we have in this statement. When proton and alpha particles which are initially at rest are accelerated by the same field for the same interval, de Broglie wavelength for alpha particle is less than that of a proton. Statement. In the given electric field, to get particular momentum of the time of acceleration is a uniformly property to the charge. We have an options. Let us see the solution of this question. So T is same, proton, which is a V is equals to AD because in the starting that will be 0. So we have a MV is equals to QE till T. T is a particle where V is to QE by E. If I just solve this value, we get the value of a potential. So after solution, we can say that we have a second option is the correct answer. Next question we have statement 1. Proton and neutron are projected with same velocity normal to electric field of same strength requires different times of space or travel to acquire velocity the same magnitude. The second statement we have in electric field is getting certain velocity from rest. The time of acceleration is inversely proportional to specific charge of other particles. So, options we have statement first is true, statement second true. Statement second is the correct explanation of a first. Statement first is true, statement second true. Statement second is a not correct explanation of a statement first. Statement first is true, statement second is a false. Statement first is false, statement second is true. So the correct answer for this question is option first. Let us see how the first option will be correct. So we have V is equals to QE by MT plus U. We know that V is equals to U plus AT and F is equals to MA if the charge is moving, and in the electrostatic field if it is moving, so this will be QE. From this equation first and second, we can say that MA is equals to QE. From here, we can calculate the value of A, which is a QE by M. This acceleration value, I'll just put it here and get this result. Next, from this, we can say that V is a proportional to the QE by M into T, and T is directly proportional to the MV by QE. According to this, from above, it is clear that V is directly proportional to Q by M times E divided by T. According to that, the correct option is first. Next question we have a statement first. A circle is drawn with a point positive charge and its center. The work done in taking a unit positive charge once around it is a 0. Second statement, displacement of a unit positive charge is 0. Statement first is true, statement second true. Statement second is a correct explanation for statement first. Statement first is true, statement second true. Statement second is not the correct explanation for statement first. Statement first is true, statement second is a false, and statement second is a first is a false, and statement second is a true. The correct answer for this question is option 2. Let us see how it is possible. So, we know that for a point charge, concentric circle is an equipotential surface. Displacement is not 0, but delta V can be 0. According to that, The correct option is option 2. Next question we have a statement first. When two charges sphere are connected by a conducting wire, the charge flows from the smaller sphere to the larger sphere. Statement second. Smaller sphere is at high potential when equal charges are imparted to both the spheres. Statement first is true. Statement second true. Statement second is the correct explanation for statement first. Statement first is true. Statement second true. Statement second is a not correct explanation for statement one. Statement first is true. Statement second is a false. Statement first is a false. Statement second is a true. The correct answer for this question is option A. Let us see how it will be possible. We know that sigma is proportional to 1 by r. That is, smaller the radius, larger the density. So, charge flows from smaller to higher. According to that, the correct answer for this question is option. Next question we have a statement. Electric potential at any point on the equatorial line of an electric dipole is 0. Second statement we have electric potential is a scalar. Now we have these options. Statement first is true, statement second is true. Statement second is the correct explanation for statement first. Statement first is true, statement second is true. Statement second is a not correct explanation for a statement first. Third, statement first is true, statement second is a false. Statement first is false, statement second is true. Let us move on the solution part. So we know that V due to electric dipole at any point. So the second option is correct. That point will be 1 by 4 pi epsilon naught p cos theta by r square. The next question we have. Question number 44, statement first. In bringing an electron towards a proton, electrostatic potential energy of the system increases. Second statement we have. Potential due to proton is a positive. Statement first is true. Statement second is true. Statement second is the correct explanation of for statement first. Statement first is true. Statement second true. Statement second is a not correct explanation for statement first. Statement first is true. Statement second is a false. And last we have a statement first is false. Statement second is true. The correct option is statement first is false, statement second is true. Let us see how it will be possible. On equatorial line, every point is equidistant from both the poles. Hence, electric potential is work per unit charge, so it is a scalar. According to that, the correct option is option 4. 45 question we have. Statements. Statement first. The surface of a conductor is an equipotential surface. The second statement, conductors allow the flow of charges. We have these options. Let us see the solution of this question. So, if the surface of a conductor is a not equipotential surface, the field would not be radial to the surface. The conductor has a free electrons. According to this, the correct statement for this question is the first. That statement is a true, statement second is a true. Statement second is the correct explanation for the first one. Next question we have. Statement first. When charge is shared between two conductors, then there is no loss of charge, but there is a loss of electrostatic energy. Second statement we have a law of conservation of energy phase. Statement first is true, statement second true, statement second is the correct explanation for statement first. This is option first. Second option we have statement first is true, statement second true, statement second is a not correct explanation for the first. Third, statement first is true, statement second is a false. Fourth, statement first is false, statement second is true. The correct option is option 3. Let us see How it will be possible? So, from conservation of a charge, when charge is shared between two conductors, total charge remains same. As a final charge, not same. Their charge in a potential electrostatic potential energy. The total energy remains same. According to that, the correct option is option 3. Now, we are going to do the questions which is based on the capacitors. Condenser stores charge, energy, both, none. The correct answer for this question is condenser stores electrical energy. That means option 3. Next we have a condenser is charged by connecting to a battery and the battery is disconnected. If the dielectric slab is introduced between the plate, potential decreases, capacity decreases, potential increases, charge increases. So, potential decreases. This is the correct explanation for the first option. How the potential decreases? So, we know that the value is, if the dielectric is inserted, so there will be change in the, or we can say change or difference in this electric field comes in the nature. That's why potential decreases. To conductors when connected by a wire, charge flow if they have different charge, different potential, different capacities, different charge densities. We have a solution. Charge flows only when there is a potential difference. That means the second option is the correct answer. Next question we have. In a charged capacitor, the energy is stored in the field between the plates, the positive charge, the negative charge, none of the above. The capacitor energy is stored in the field between the plates. According to this, we have the correct answer is material. Next question we have. The capacity of a parallel plate condenser depends on the material of the plates, its charges, its potentials, none of the above. Capacity of a parallel plate capacitor. C is equals to K epsilon naught by D. According to that, the correct answer for this question is option 4. Hope you understand this much. Now, move on the next question. Next question we have. The capacity of a parallel plate condenser can be increased by decreasing the distance between the plates, increasing the area of the plates, introducing a dielectric slab between the plates, all of above. Let us see the solution of this question. For parallel plate capacitor, we have C is equals to K A epsilon naught by D. According to that, we can say decreasing the distance between the plate can increase the condensity or the capacity of the capacitor. Increasing the area of the plate, increase the capacitance. Introducing the dielectric slab between the plates, that means capacitance will be increased that time also. Next question we have. The condenser used in the tuning circuit of the radio receivers is paper condenser, electrolytic condenser, Leyden jar, or can condenser. So let us see the solution of this question. In tuning circuit, GAN capacitor is used because capacity is variable. Hence, the correct option is option 4. Next question we have. The condenser having predetermined polarity is called ceramic condenser, paper condenser, electrolyte condenser, mica condenser. Solution we have. Electrolytic condenser or capacitor have a predetermined polarity. That's why we can say correct option is option 3. Next question we have. Electrolytic condenser have a aluminium oxide as dielectric medium. Have very low capacity because The plates are widely separated. Can be used both AC and DC circuit. All of the above are true. So, solution is aluminum oxide is used as a dielectric medium. So, the correct option is option 1. Next question we have a parallel plate air capacitor is connected to a battery. The quantities, charge, voltage, electric field and energy associated with this capacitor are given by Q0, V0, E0 and U0 respectively. A dielectric slab is now introduced between the plates with the battery still in a connection. The corresponding quantities now given by QVE and U are related to the previous ones. Q is equals to Q naught, V is greater than V naught, E is greater than E naught, and U is greater than U naught. So, for this, energy stored in a charge increases. That's why the correct option is a 4. Next question we have, when two charge condensers are connected in parallel, options we have, the electrical energy of the system is conserved. The total charge of the system is conserved. Both charge and electrical energy are conserved. Neither charge nor electrical energy is conserved. Solution we have charge and electric energy are conserved. Hence, we can say the correct option is option 2. Next question we have the plates of a charge condenser are connected by a conducting wire. The quantity of heat produced in the wire is proportional to the square of capacity of a condenser, inversely proportional to the square of the potential of the condenser, proportional to the length of the wire, independent of the resistance of the wire. Solution we have plates of a condenser are connected by conducting wire. The heat produced in the wire is independent of the resistance of a wire. Hence, we can say the correct option is option 4. Next question we have. A parallel plate condenser is connected to a battery and charged. Then the battery is disconnected and distance of separation between the plates is increased with the help of insulated handles. Then capacity and charge decreases. Potential and charge increases. Capacity decreases and charge remains same. Energy and capacity decreases. Solution we have capacity decreases, C is equals to epsilon naught A by D, but charge remains same. Hence, the correct option is option 3. Next question we have a parallel plate condenser is charged by connecting it to a battery. A battery is disconnected and a glass slab is introduced between the plates. Then potential increases, electrical intensity increases, energy decreases, capacity decreases. The solution which we have, when dielectric slab is introduced without battery, capacity increases and UVE decreases. Hence, the correct option is option 3. Next question we have an aluminum foil of a negligible thickness is inserted between the plates of a parallel plate capacitor or condenser such that its length is parallel to the plates. If the foil is electrically insulated, the capacity of condenser will be increase, decrease, remains unchanged, becomes. Let us see the solution. Aluminium is a conductor where K is equals to infinite. So we can say that decreases considerably. Now we have next question. A capacitor works in AC circuit, DC circuit, both circuit, neither AC or nor DC circuit. Solution we have capacitor works with AC DC but it stops DC and allowing AC. That means both the circuits. Next we have a question. Two identical capacitors are joined in parallel charged to a potential V, separated and connected in series, that is, the positive plate of one is connected to negative plate of other. The options we have: the charge on the plate connected together are destroyed, charge on the free plates are enhanced, the energy stored in the system increases, the potential difference between the free plates is 2 volt. Solution: when connected in series, the potential becomes 2 times of each. Hence, the fourth option is correct. Next question we have: out of the following statements, the capacity of a conductor is affected due to the presence of an uncharged isolated conductor. The second statement: the conductor can hold more charge at the same potential if it is surrounded by dielectric medium. Options: both A and B are correct. Both A and B are wrong. A is correct, B is wrong. A is wrong, B is correct. The correct option is option 1. Solution we have: capacity of a conductor affected due to the presence of uncharged isolated conductor because a capacitor is formed. In the presence of a dielectric medium, potential decreases, so a conductor can hold more charges. That's why the correct option is option 1. Next question we have: a parallel plate capacitor has a plate of unequal area. The large plate is connected to the positive terminal of the battery and the smaller plate to its negative terminal. Let plus Q and minus Q be the charges appearing on the positive and negative plate respectively. Options we have: plus Q is greater than minus Q, plus Q is equals to minus Q, and plus Q is less than minus Q. The information is not sufficient to decide that relation between plus Q and minus Q. Solution we have: irrespective of area, magnitude of charge on both plates is same. Hence, we can say that the correct option is option 2. Next question we have: space between the plates of a parallel plate capacitor is filled with a dielectric slab. The capacitor is charged and then supply is disconnected to it. If the slab is now taken out, then work is done. To take out the slab, energy stored in the capacitor reduces. Potential difference across the capacitor is decreased. Potential difference across the capacitor is increased. The option correct is a 4th. Let us see the solution. In the presence of a slab, the potential of a capacitor is Vc by K. When the dielectric is removed, potential increases. Hence, we can say correct option is a 4. Next question we have: a small uncharged metallic sphere is positioned exactly at the midway between two equal and opposite point charges. If the sphere is slightly displaced towards the positive charge and released, then it will be moved further towards the positive charge. Its potential energy will decrease and kinetic energy will increase. The total energy remains constant but is non-zero. All the above are correct. So the correct answer for this question is all the above are correct. How? Let us see by the solution. If we just taking two different kind of polarities charges, being a metal sphere, it is introduced with a negative charge, potential energy decreases and kinetic energy increases. Due to the attraction, energy is conserved. Hence, we are say that the correct option is option 4. Next question we have: the capacity of the parallel condenser is quadrupled if the charge on its quadrupled, if the potential difference is a 1/4 of original value, the area of each plate is doubled and the distance of separation is half, all of the above. So the correct answer for this question is by seeing the solution, we can explain. So C is equals to Q by V. We can say that all the above are correct because as you can see here, C is directly proportional to epsilon naught. C is directly proportional to A also. and C is inversely proportional to D. So that's why we can say if the charge is quadrupled from here, then capacitance quadrupled. If the potential is a 1/4, then it is a quadrupled. If the area is a double, so we can say the distance is a half that time. So we can say that is a quadruple. So according to that, all the above are correct. Next question we have. A parallel plate condenser is charged by connecting it to a battery. Without disconnecting a battery, the space between the plates completely filled with the medium of a dielectric constant K. Then potential becomes 1 by K times, charge becomes K times, energy becomes 1 by K times, electric intensity becomes K times. So solution we have a charge and energy increases. Hence we can say that charge becomes K times. Next question we have in the diagram A and B are two metal plates arranged as shown. A small particle having a mass small m and a negative charge q is held at rest at point P. A constant potential difference is applied between A and B plates. At a higher potential, the particle is then released. Its path as it falls will be best represented by the curve. So this is the diagram. This P point initially at rest, and this A and B have applied. This is the potential difference. These are the options. Solution we have. Particle moves in a parabolic path towards positive plate. Hence, the correct option is option 2. Next question we have. Two vertical metallic plates carrying equal and opposite charges are rest kept parallel to each other like a parallel plate capacitor. A small spherical metal ball is suspended by a long insulated thread such that it hangs freely in the center of two metallic plates. The ball, which is uncharged, is taken slowly towards the positively charged plate and is made to touch that plate. Then the ball will stick to the positively charged plate, come back to its original position and will remain there, oscillate between two plates touching each plate in turns, oscillate between the two plates without touching them. So, the correct answer for this question is option 3. Let us see the solution how it will be possible. When ball is brought towards positive plate, negative charge is introduced. So it is attracted by positive plate. When touches the plate, it becomes positively charged and repel, moves the other side and oscillate. Hence, the correct option is 3. The next question we have a condenser A of a capacitor 4 millifarad has a charge 20 microcoulomb and another condenser B of a capacity 10 millifarad has a charge 40 millicoulomb. If they are connected in parallel, then charge flows from B to A till the charges on them are equal. Charges flows from B to A till common potential is reaches. Charges flow from A to B till common potential is reaches. Charge flows from A to B till charges on them are equal. The correct option for this question is option 3. Let us see how it will be possible by then seeing the solution. Solution we have VA is equals to QA by CA, we know. So the value of QA is given 20 and the CA is 4. Hence the correct option answer for VA is a 5 millivolt, VB is 4 millivolt, vice versa. So VB is a less than VA. Charge flows from A to B. Hence the correct option is 3. Next question we have when a dielectric material is introduced between the plates of a parallel plate capacitor, then the capacity becomes K times 1 by K square times K square times and 1 by K times. Solution we have C is equals to Kc naught. C naught is equals to epsilon naught A divided by T. Hence, the correct option is option 1. Next question we have, if the electric intensity between the plates of a parallel plate condenser is E, the electric energy stored per unit volume of the medium is 1 by 2 epsilon naught E square, 1 by 2 E epsilon naught square, epsilon naught E square, and 2 epsilon naught E square. Solution we have, energy stored per unit volume in bracket energy density. E by V is equals to half epsilon naught E by D, V square by V is equals to half epsilon naught E square. Hence the correct option for this question is C. Next question we have, two condensers of capacities C1 and C2 are connected in parallel and charged. Then the ratio of the charge C1 to the charge on C2 is ratio C2 by C1, C2 by C1 whole square, C1 by C2 or C1 by C2 whole square. So let us see on the solution firstly. Potential on the both are equal. So V1 is equals to V2. Q1 by C1 is equals to Q2 by C2 is equals to Q1 by Q2 is equals to C1 by C2. Hence we can say that the correct answer for this question is option 3. Now next question which we have, a parallel plate condenser of area A has a charge Q, then the force on each plate is Q square by epsilon naught A, Q square by epsilon naught square by A, Q square by 2 epsilon naught A, 2Q by epsilon naught A square. We have the solution. Each plate is in the electric field of other plate is F is equals to Q. E is equals to sigma by 2 epsilon naught into Q, which is the sigma by 2 epsilon naught is the electric field of a parallel plate. We know that sigma is equals to Q by A. From here we can say that Q is square by 2 epsilon naught A. Hence the correct option is 3. Next question we have, you are given 3 identical capacitor. How many different combination you can make using all capacitor each time? We have these options. Let us see the solution of this question. So n capacitor will be arranged n plus 1 ways. Hence the correct option is 4. Next question we have, a parallel plate condenser has a charge Q, surface charge density S, capacity C, and distance of separation B between the plates. Then electric intensity between the plates is sigma by 2 epsilon naught 2Q by CD to sigma by epsilon naught Q by CD. So solution which we have, E is equals to sigma by epsilon naught Q by A epsilon naught is equals to Q by CD. Hence the correct option is 4. Next question we have, two spherical conductors of radii R1 and R2, R2 is greater than R1, are placed concentrically in air. The two are connected by a copper wire. Then the equivalent capacity of the system is the options are these. Let us see the solution. It is a combination of a sphere on separate capacitors. So the correct option is option 2. Next question we have, 3 identical condensers are connected in different combination using 3 each time. Arrange the following cases in the increasing order of effectively all in series, first option, all in parallel, 2 in series, 1 in parallel, 2 in parallel, 1 in series. So these are the options. Let us see the solution of this question. All are in the series. So the final, which is a 4 C naught. Hence, all in series, that means C naught by 4. So we can say that 2 in series, C1 is equals to 2C, and 2 in parallel. That's why the result will be 3 by 2C. So in the above case and from the last case, we can see that the correct option is option 1. Next question we have. A capacitor of a capacity C1 is equals to 1 farad is a charge to a potential of 100 volt. The charging battery is then removed and it is connected to another capacitor of a capacity C2 is equals to 2 microfarad. The other plate of a C2 is earthed. Then the steady state, the charge on C1 is 100 microcoulomb. The charge on C1 is 50 microcoulomb. The charge on C2 is 0. The charge on C2 is 50 microcoulomb. A and C, A and D, B and C, B and D. So, the correct option for this question is 2. Let us see how it is possible. As V is same, so Q1 by C1 is equals to Q2 by C2. We just put all these values and get the value of Q2, which is a 50 microcoulomb, and by the value of Q2, we can find out easily the value of C1, which is C is equals to QV. We just put all these values and get the result. The question number 84, we have the strength. There will be first statement. The strength of an electric field is charged and isolated capacitor is decreased when dielectric slab is inserted. Second statement we have. When dielectric slab is inserted between the plates of a charged capacitor, electric field is generated due to introduced charge opposite to external field. Statement first is true, statement second is true. Statement second is the correct explanation of a first. This is an assertion type of question, mostly comes in the exam. Statement 1 is true, statement second is true, statement second is a not correct explanation of a first. Statement first is true, statement second is a false, and statement first is a false, statement second is true. The correct answer for this question is option first. Let us see how it will be possible. So, we have when dielectric slab is introduced between the plate, electric field strength decreases due to introduced charge in the dielectrics. Hence, we can say by this statement the correct option is option first. Next question we have, again a such a reason type question. Statement first, when a condenser is charged by a cell, then the energy stored in the condenser is a half of the work done by the cell. Statement second, we have a condenser is a charge at gradually increasing potential, but the cell gives charge at a constant potential. We have these options. So, the correct option for this question is option 1. Let us see the solution of this question. So, work done by the cell is equals to QV and energy stored in the capacitor is a half QV. According to this, the correct answer for this question is option 1. Next question we have statement 1. On charging the capacitor, energy is stored in it. Statement second. In charging the capacitor, work is done by the battery. We have an options are these. Statement 1 is true. Statement second is true. Statement second is the correct explanation of a first. Statement first is true. Statement second is true. And statement second is not the correct explanation of a first. Statement first is true. Statement second is a false. Statement first is false. Statement second is true. The correct statement is an option 2, that is a statement 1 is true, statement second is true, but second statement is a not correct explanation of first. By which particular example or by which particular phenomena, I'll just take in this option correct. Let us see by the solution. On charging capacitor, electric field is stabilized between the plates, so energy is stored in the field. Work done by the cell move the charges. According to that, the second option is the correct option. Next question we have again assertion reason type. So statement first, when dielectric is placed between the plates of a capacitor with disconnecting by the battery, energy stored in the capacitor decreases. Statement second, due to dielectric slab increases. We have these options. The correct option is option 2. Let us see the solution. When battery is removed, the dielectric is introduced, then Q on the plates does not change, but V decreases, capacity increases. According to that, second option is a correct option. Next question we have. Again, assertion reason type. Statement 1. Two capacitors are connected in series to a battery. If dielectric medium is inserted between the plates of one of the capacitors, the energy stored in the system will be increased. Second statement we have, on inserting the dielectric medium, the capacity of the capacitor increases. We have these options. The correct answer for this question is option first. Let us see the solution of this question. When dielectric slab is inserted across one of the capacitors, the energy stored increases. Capacity also increases. Hence, the correct option is first. The next question we have, two capacitors are connected in the parallel to a battery. If a dielectric medium is inserted between the plates of one of the capacitor, then the energy stored in the capacitor will increase. This next statement we have, on inserting dielectric medium between the plates of a capacitor, its capacity increases. We have these options. The correct option for this question is option first. Let us see the solution. Capacitor connected in parallel potential remains same on inserting dielectric slab, but the capacity increases. So energy stored, the capacity is increases. By this formula, we are saying these things, that energy U is equals to half CV square. Next and the last question which we have. Statement first, when a charged capacitor is discharged through a resistor, heat is produced in a resistor. Statement second, in the charging a capacitor, energy is stored in the capacitor. Statement 1 is true. Statement second is true. Statement second is the correct explanation for the statement first. Statement first is true. Statement second is true. Statement second is not correct explanation of the first. Statement first is true, statement second is false, statement first is false, statement second is true. Second option is the correct option. Let us see the solution for this question. When the capacitor is discharged through a wire, heat is produced on the charging. Electric field is established and energy is stored. According to that, the second option is correct. So, thank you everyone. I hope you more and more thing learn in the series. So revise that series again. Till that, take care everyone.